Hey, good morning everybody. What I thought I'd do is try and put together a little video that explains a little bit the family tree data structure that you have to use in order to draw your family trees for the coursework. Okay, so the whole data structure is made up of two objects. You have the person object and the partnership object, and you need to use both of them in order to have a whole tree represented. And that's because if you look at these relationships between the two, there is no direct link from a person to another person, and likewise there is no direct link from a partnership to another partnership. So in all of your algorithms for traversing the tree, you're going to need to have parts of it in both of the objects in order to navigate the tree. So I'm going to have a look at this now. Starting with the person object, and you'll notice in your example code that's been given in the main JavaScript file, you have a person object, top person, returned by the example fault trees object. So you have somewhere to start with your tree. Now, a person object has in it an array which has links to partnership objects. Okay, so this partnership relationship, a person may have one to many, essentially, partnerships. They may also have no partnerships. So there are some individuals in the tree, such as Harry, who doesn't have a partnership, and therefore he is by himself. But it's that relationship. A person has one partnership. So the partnership object also has an array in it, which contains links to the two partners that are in that partnership. So you have a relationship of 1 to 2, so you have one partnership, and that has links to two person objects. Now, one of those person objects is going to be the original person that linked to the partnership, and the other one will be the other person in the partnership. So it takes two people to make up a partnership. In the case of the first tree in the list, we have William and Kate. So if we start with William, there is one partnership for William, and that partnership has two partners in it, William and Kate. So there'll be links to both of those, and I'll explain that in more detail on the next page. So also in the partnership object is another array, and this array is also containing person objects, and that is all of the children of the partnership. So in the case of William and Kate's partnership, there are two person objects listed as children, who are George and Charlotte. So that relationship is one partnership, it might have no children, as is the case with Charles and Camilla, but it might also have an unlimited number of children. I don't know, Elizabeth has 4 children in her tree branch. So, okay, what we'll do next is we'll look a little bit more at an actual example of that family tree data structure as it's been instantiated. Okay, so we just looked before at the person and the partnership objects, more of their class-like nature, and now we're going to look at an actual sort of instantiation of that data structure using them. So what I'm going to do is I'm going to use my black pen for noting person objects, and I'll use a different color in order to show partnerships. So let's start off with William, who will be the top person in our example fault tree. So William, he has in him that M partners array, and that links to an array. So it could have lots of cells in it, but in actual fact it only has one partnership, and that is, let's use red. Nope, we're not going to use red because it's running out. We're going to use blue instead. Okay, so I'm just going to give it a name, although it doesn't actually have one. So the first partnership has an array in it. And that array, as we said in the previous part of the video, has 2 cells in it. So the first one is going to point back to William, because he's the first person in that partnership. The second one is going to point to Kate. So Kate is also going to have her M partners object in it, and that's going to point back to an array which could have lots in it, but actually it only has one, and that one points to here. And I realise that I've already broken my colour rule. Possibly it was difficult to tell anyway on the video. But anyways, let's find another way of noting it. So pink. Pink for a person. And blue for a partnership. Okay, so far so good. We've got 2 person objects and we've got a partnership object which is linked to each of those person objects. We can also have in here another array which points to all of the children of this partnership. So in the case of this particular partnership, there are 2 person objects in it. One of them is George, and the other one is Charlotte. Now these also will have M partner arrays in them. But in both cases, they are empty. So that's the perils of trying to make a video in your office. I had some people coming in, but getting back to it. So yeah, George and Charlotte are both person objects, and I think that I was saying that both of them have their M partners array, but they're both empty because there are no partnerships there. So that is basically the William top node, the top person, and how those relationships happen. So a quick review of those again. So we start off with William. He has an array of M partners. It has one partnership object in it, which is this one. That partnership object has an array of person objects that contain 2 person objects, the persons that live inside that partnership. So we have a link back to William, the original, and a link to Kate, who is the other partner in that relationship. So this partnership also has an array of child person objects, and in this case it has two of them. One is to George and the other is to Charlotte, both person objects. So they both have partnership arrays, but they are both empty because they don't have any partners, because they are tiny children. Okay, so there's that one. Now, looking back, or looking further, let's consider the next sort of level up in your tree structure. So we have Charles, and Charles has his M partners, which links to an array. Now in this case there are two elements in that partnership array. We'll deal with the easy one first, which is the second one. So that just links to, let's call that partnership 3. It has M childs, which is empty array, and it has M partners, which has the two items in it. One of them links back to Charles as the first partner in that array, and the other one links to Camilla, who also has an array with one partnership in it, which points to this partnership. So I'm trying to remember now, I think it was pink for a person and blue for a partnership. So that's a nice simple partnership. It's a partnership that doesn't have any children, and it just has those two people in it, Charles and Camilla, as the partnerships. So Charles's other partnership is, call it partnership 2. That 2 has its partners array and its child's array. So let's see, the partnership array up here has two people in it. One of them is Charles and the other one is Diana. Still on the page here, yep. So Diana has her partners array, which has one item in it, which links back to that partnership with Charles. Okay, so we also have the M childs array, and again this one has two children. So one of them, second one, is Harry, and Harry has an empty array of partnerships because he doesn't have any, and the other one is William. Now, I'm not going to fill in William stuff because if we refer back to our previous version, that is that William, and that's how it links into the rest of that branch. So there isn't anything special about William in this. He's just another node in the tree. So when we start off, the first tree that gets handed out is just William as the top node, and it's his family tree. But if we go further up the tree, Charles, as the top node of that particular tree, includes William in it. Now, the important thing about traversing all of these trees is that you remember that each of the objects has a particular responsibility, and that you shouldn't be mixing the responsibilities between them. A person doesn't have a link to another person, so there shouldn't be any code in there that is saying let's see, m partners 0 dot get child I, for example, because this person doesn't have a link to the child, and you shouldn't be artificially giving them one either. All of the responsibility for handling child behavior and other person partners belongs in partnership, and that's why there are the functions in there for getting a child and getting a partner. So that behavior is in there for traversing between two other partners and traversing to the children. Likewise, in the partnership object, you shouldn't have any behavior in there that is going to another partnership. So for example, you shouldn't have get partner 0 dot get partner 1, for example, because the partnership doesn't have access to other partnerships, and you shouldn't be adding that responsibility artificially. So for traversing this tree, for example, we would start off with William, and remember that the behavior isn't because he's William, but because he's a person object. William is a person, which means that we know that there is an array in there of m partners. Now, as in some cases, that array may be empty, but that doesn't matter, because if you're dealing with a generic for loop, let's say, for looping through each of the elements in the array, then you don't need to worry about is there 1 or is there 2 or any of that sort of thing, because you just loop through each of the partnerships that are in the person object and tell them to do whatever it is, the action that you want them to do. So in the case of, let's say we want them all to draw, so we're doing a draw traversal, you might say in here, get partner I inside a for loop dot draw, and give it the context as a parameter, and that will cause this partnership object to activate its draw function, which is what we're trying to do. Likewise, in the once we're in a partnership object, so we're in the draw function of the partnership object, we know that we have a certain amount that we have to do as drawing our partnership object, which is to draw that nice little pentagon shape using the circle drawing algorithm in my slides. Now, apart from that, we also know that we need to access the other parts of the tree. So we have 2 arrays in there, which means that we're going to need 2 for loops to go through them. One of them is the partners array, so we can link through to the other people there. By, again, it's get partner I and dot draw, which will trigger each of these to draw. And the same inside the child for loop. You go through get child I dot draw, giving it the context again, which will trigger these to draw themselves. Now, each of the draw functions in the person object and the partnership object are separate, and they handle their own responsibilities. So the draw inside the person object will draw the frame and the photo and the name, and the partnership object will draw its little pentagon and all of the lines connecting the members of the partnership object. But they'll each do that separately from each other, and when you call them. So yeah, that's that, and it works exactly in the same principle when you start looking at the larger trees as well. So Charles is a person, so he has an array of partners, so he will draw himself, then he will draw each of his partnerships, or tell his partnerships to draw themselves, to be more precise. Then this partnership will draw itself with its little pentagon, and then it will go through and loop through each of its partners and each of its children and tell them to draw themselves. And so the traversal continues, and ultimately everything inside the tree will get drawn because the traversal is complete. Now, there is a slight obstacle to getting that to work correctly, and that's covered in the forum post on Stack Overflow. And that is the issue that, if I go back here, that let's say we start at William. Now William goes to his partnership object, and we loop through the partnership object, partners, and the first element in there is a link to William. So we go back to William and tell him to draw, but part of drawing William says that we have to draw his partnership, which takes us this to Earth array, and back and round and back and round and back and round. So that's one possible infinite loop there that we need to be careful of. Another one is this. So we start at William, we go to the partnership, say we are not going to do the first partner, we're going to do the second partner. Okay, so far so good. So we go into Kate, because she's the other partner in there, and we tell her to draw. But part of drawing her means that we go to this array, which means that we go to this partnership, and that's going to draw again, because this is going to cause this array to draw, which is going to cause Kate to draw, and round we go in this loop. Another possibility is that we get to here, and then loop back to here, and then back to William, and then on we go. Okay, so those are a couple of situations where you end up with infinite loops that you want to avoid. Now, probably the most straightforward way to get around this is, rather than putting in special cases for is that the second person in the partnership, or things like that, because you're at risk of hard coding a solution which the assumptions for will break later on, is to use a visited flag in your person and your partnership objects. The way of getting around the Stack Overflow issue is to essentially prevent each of the objects from drawing more than once. Okay, because if they're drawing more than once, then you're essentially getting into a loop, and the loop goes on forever, so you get a Stack Overflow. So what we can do in each of our objects, and to make it easier for you to know what we need in terms of functions, inside the person object and inside the partnership object, there are both a set and a get ID function in there. Now, you don't actually need to use those, but if you copy and paste each of those functions inside their relevant object, then you can change the word ID in each cases to visited or flag, or some meaningful variable name that you want to use, and then you have two ready-made functions for traversing the tree. So let's start in person. So let's say we're going to do a draw traversal. So inside the draw, we start with William as the top person, we come inside, and the first thing we do is ask whether or not we have visited this object before. So we say, if this.getVisited equals false, i.e. it hasn't been visited before, then set the flag to true. Okay, that's the first step, because we need to make sure that we have now visited this object. And then do your drawing code. So say things like, draw the frame, draw the photo, draw the name, all of that kind of thing. And then tell the partnership object to draw. Okay, so we're going through our own partners array and our loop, getting it to draw. So now we're inside the partnership object. And the same applies here. You probably want to stop the partnership from drawing more than once, although you may get away without having this code inside partners. But essentially, you have your visited flag inside partnership too. So in your draw function of partner, you can start again by saying, if this.getVisited equals false, then do stuff. Okay, so the first thing to do is to set it to true. So this.setVisited true. Then you can do the drawing of the partnership object, so the pentagon and the loops for all of the partners and the children objects, and starting with that, we'll loop through to this array where we'll go to William, and the first thing that we do inside the drawer of William, of the person object, is to say, if this.getVisited equals false, which we know it isn't, because the last time we were here we set it to true. So because it isn't false, we just ignore it. We don't do anything. We don't do any drawing, we don't do any traversal. The function just exits. So we essentially backtrack back to here and do the next one in the array, which is Kate. Now we go to Kate and her draw function, we check to see whether or not she has been visited. So again, she's just a person, so we deal with it in a generic person way and say if this.getVisited equals false, then do the drawing code. Now we know it is false, so the first thing we do is set it to true, then we do our drawing code, which will tell it to loop through to the partnership object to draw. Now if we've set up the flag inside the partnership object as well, then the same will apply. We'll get to here, it will say I've already been drawn, so we'll backtrack back to Kate, who will then finish back to here, and now we have done that without looping through to the and actually doing any of the draw actions more than once, which is exactly what we're trying to achieve. Now, in order to stop the algorithm from basically only working once, i.e. the first frame that you do it, and this is particularly an issue if you've got it running in an animation loop, you need to include code to reset the flag back to its original state. Now, probably the easiest way to do this is inside the draw functions of each of your objects, the very last thing you do inside the if of the if statement of if this.getVisited equals false is to set the flag to false. Okay, so this is after the calls to get the next object in the loop. Okay, so we have done our recursive go through into the different objects, and we just want to do it as the final thing in that if statement, just set the flag to false. Now, because we've already set up the situation where you can't end up in a loop from further down the tree, we don't have a problem with this because of the way that recursion works. It will just bubble out, set the flag to false as it leaves, and then at the very last stage it will exit William and the tree traversal will be complete. We won't have drawn anything more than once, and the flags for all of the objects will be set to false, which is what we want, because when we come to do the next frame of the animation, or the next time we draw it, we want it to be able to draw completely fresh without having to worry about the flag sets. So that is basically a walkthrough of how you can traverse the tree without worrying about causing a stack overflow, and how the relationships between all the objects work.